Welcome back to the University of Queensland School of Architecture introductory series on Rhino and Grasshopper. Now, in this final part of the videos for the Twisted Tower, we're going to introduce some perimeter columns to our tower here. So what I'm presuming is, I've turned on my core, is that we're going to have a column-free open space for the offices with a row of columns around the outside. Now these columns will twist with the tower itself so that the whole thing works as one system. Now there's probably a number of ways you can do this, but the way I'm going to do it will hopefully make the sequence of relationships a bit clear. But I'm fairly certain that there's probably a simpler way of doing it, and I welcome any feedback if anyone comes up with a brilliant and very simple solution. So what I'm going to do is that I'm going to take this surface here, and I'm going to offset the surface to generate some lines that I will then divide up into points that will be the base of my columns, and then I'm going to do the same to the underside of the slab above. I'm going to offset it, put some points, and then in an exercise similar to the data matching, I'm going to connect the points with the underside of the slab with the top of the slab below. So connecting the base of the column with the top of the column. So let's proceed. So I'm going to turn off my extrude there, and I'm going to turn off my floor slabs, but I'm going to turn on my boundary of my slab. So the first thing that I'm going to do is I'm going to duplicate this to the ceiling above. So what I'm going to do is I'll start with a addition. Now the distance that I'm going to have to move this boundary surface up will be the distance of the floor to floor, which is 3.6, plus the slab thickness, which is a negative integer because the slab goes down. So it's 3.6 plus minus 300, which will give us effectively an underside. I'm going to do a translation vector, unit Z, for the move, and I'm going to get a move command, plug that in, and the geometry that I want to move is this boundary geometry through here. Now it's moved this geometry straight up, which is not quite what we want because we want this surface to align with the underside of the slab above, which is already rotated one rotation. So we're going to have to now rotate that slab, rotate along a plane. There's the geometry, and we're going to borrow the same step rotation through here. Remember how we set that up? Oops. From this input here. So we'll pop that into the degrees input of this radian converter, the angle, and now all of a sudden we can see that we have our slab that's copied up but rotated slightly as per the step as we go up the floors. Now what we're going to do is I'm going to run two parallel sets of relationships, one which is going to be the base of the column or the top of the slab, and one which is the top of the column or underside of the slab. Now I'm going to use the offset command through here, and I'm going to duplicate this surface through here, and I'm going to, I'll do that again, offset, and the second one will be the geometry that we created here. Now the offset distance, I've already set up some parameters in the final file. I've said column offset distance from facade, and it's a negative integer, so it's always going to step inwards from the outside of the surface. So I'll find my way there, and I'll connect that into there. I'll connect that into there using the same slider so that they're offsetting the same distance, and you can see there as I move that number slider, that offset grows and shrinks in relation to the edge of that slab. I'm now going to extract the edges and corners of this offset that I've created, and I'm going to use the deconstruct brep for that. So I'll just copy and paste that, connect these two together. I'll turn that off, turn that off. Okay, I'll turn that preview off there, and I'll also turn off our boundary surface up here. Okay, so now we've got two surfaces where we can actually extract the edges from there. Now, I'm going to be a little bit tricky because at the moment we're working with a base geometry that's square. Now, I want to be able to work with a variety of base geometries, some that may be rectangular. So I'm going to make the assumption that it's a four-sided floor slab, but I don't want to restrict myself to having it to be a symmetrical shape. So the important thing when we're developing up grasshopper routines is that we can redeploy them as solutions to other future problems, and so the effort that we put into creating these tools will be recouped downstream, and for an office that's extremely valuable. Now, to do that, what I'm going to do is dispatch or separate the even-sided edges with the odd-sided edges, whether one's odd or one's even, irrespective. So these two are going to be on one list and these two are going to be on another. I'm going to do a dispatch, and what that will do is from my list, which is my edges through here, I've got a true false value as the default. So what that's going to do is it's going to just simply split the list in two. So it's going to do the first item and put it in list A, second item, put it in list B. But in this instance, we've got 4 items coming through here, so it'll go true false. So it'll go true, that list A, that will go on list B, then it'll repeat, and that'll go on list A, and then it'll go on list B. So what I will get out of this is one list with opposite edges through here, and the other list with these opposite edges through there, so that when I get a rectangular shape, then I'll be able to input values relative to the edges and not assume that it's symmetrical. So I hope you're following me there. So I'm going to do the same through here. I'll plug in the edges into that. Okay. Now, I'm just going to concentrate on this top one here for now, and I'll just quickly duplicate that further down here. So what we've got here, don't forget, this is the base of the columns, and this is the top of the columns that I've got running. So I'm going to try and do something a little bit tricky, because what we want to do is establish a maximum column spacing. So here, if we say the maximum column spacing will be 9, the minimum column spacing will be 3, we want to figure out how many times to divide this line in relation to the maximum column spacing. And if we have different floor sizes, then clearly this line length is going to be different, and the number of times we divide it is also going to be different. What I'm going to do is, from this list, I'm going to extract just the first item, because I'm assuming it's this line and this line is going to be the same, and I just want to do kind of like a sorting or a testing routine for that line. So I'm going to pull out a list item through there, and for my first list in there, and I'm going to copy that, but I'll pop that in there. So now what I've got is I've got one half of these two lines on here and the other half on these two lines through there. So the list item that I want to pull out is the first one, so I'll do a panel. So that will be the 0 item, or the remembering that the list's number off at 0. I'm going to copy that and I'll plug that into the item number through there. Okay, so what it's going to do is it's going to interrogate the first item in my list. And then what I'm going to do is I'm going to find, well, what's the length of that line? So I'm going to do, what is it, length. There it is, length of line. Now that you'll find is in curve analysis. And I'm going to copy that, do the same thing through there, and pop that in. Now, we've got a square at the moment, so these two line lengths are going to be the same. So you can see there's the line length 28 meters, and there's the same line length there, 28 meters. Now, what we want to do is we want to say divide this into the suggested minimum maximum column spacing. So let's just dial this to say around 6 meters. So we're going to get the line length and we're going to just simply divide it. I'll get a divisor through there. So that's the length of the line, and that's what we want to, there's a maximum column spacing through there, and connect that into there. So, and I'll do the same, oops, do the same here. So we've got the line length there, and we've got the maximum column spacing. Oops, come on through here. There. Okay, so what you can see is that we've got a division then of 4.6. Now, we can't divide that line into 4.6. We want to divide it into an even number. So what we're going to do is we're going to round that number. So round a floating point value. I'm going to copy, I'm going to paste that, plug that in there, plug that in there. Okay, so if I plug that in now, what you can see is that it's rounded the number up. The rounding is needed to give us a whole number that we can then divide the line into. And the additional thing that I'm going to do, if you notice here that the input, it's a very sort of complicated number, and it's going to start giving us a very complicated data tree unnecessarily. So I'm going to, you can flatten the tree like we've showed you in the data matching, but you can also do it directly out of the output from this component. So if we go into here, flatten, so we've got a simplified data tree through here, and we've got our output as number 4. So I'm going to do the same there. Okay, I'll just get rid of that. So we're going to now divide our first line, divide, okay, so we'll get the curve that we want to divide will be coming out of here. So we've got two curves. The number we want to divide it by is here, and so you can see those two curves opposite there are divided. So it's divided at 1, 2, 3, 4 times. And we'll do the same here. Divide curve. The curve we want to divide is this one here. The other one, the number we want to divide it by is that. And there you can see that one through there. So I'm going to leave it there. We'll pick it up at the next stage of this routine.